Hi, welcome back. Today we're going to talk about the distributive property, and the first example that we're going to do is involving area. On the side here you see that we have a couple of rectangles here, a blue one and a green one, and we're going to put that up against a big rectangle that uses the blue and the green one together. Let's model an expression. If I'm going to find the area of these two shapes together, I'm going to note that this rectangle here is 4 tall by 3 wide. This rectangle here is also 4 tall, but it's 1, 2, 3, 4, 5, 6 wide. If I'm going to model the area of these two rectangles, the total area is going to be 4 times 3 plus 4 times 6, which gives me 12, plus 24, which gives me 36 square units. If I hop over to this one, I'm going to notice that I have 4 tall, and of course the green one is also, now they're just joined together. And I've got 3 down here, plus the length of the green one, which is 6, so that gives me 9. So my overall width is 9. An expression that models the area of the second rectangle could be 4 times 3 plus 6, which equals 4 times 9, or 36 square units. What we're going to notice is the area remains the same. It's still 36 square units, but the expression that we used to model it was just a little bit different. What we did here was equivalent expressions, expressions that have the same value. We also used the distributive property. The distributive property says that if I have a number, A, times B plus C, notice over here, A, B, and C, the 4, the 3, and the 6, it's really equal to A times B plus A times C. So check out what happens when we expand the distributive property. If we use 4 times 3 plus 6, it was the same as 4 times 3 plus 4 times 6. Those are equivalent expressions. A way to model this with numbers would be 4 times 3 plus 6, and we distribute the 4 to each of the elements, creating two products equal to 4 times 3 plus 4 times 6. 12 plus 24 equals 36. Again, an equivalent expression would be 4 times 9, which gives us 36. We get the same answer. Down below here, in example 2, we're going to use the distributive property to write an equivalent expression. Well, in this case, kind of like up here in the distributive property description, we've got a negative 4 that's being distributed to the 5 and the 8. If I write a pair of products, minus 4 times 5 plus minus 4 times 8. What I end up with is negative 20 plus negative 32, which gives me negative 52. It works for subtraction as well. 4 times 50 would be 4 times 50, and then I subtract 4 times 3. So 4 times 50, I've got my pair of products here, keep the same sign, 4 times 3, which gives me 200, minus 12, which is 188. I'd like for you to try the last two examples on your own, see what you get, and we'll talk about them in class. Thanks for watching, guys. That was distributive property. We'll see you next time.